Here's a review for second semester final. Here are some problems that match the ones on the practice final. Finding the domain, you look at your function, and when you see the word domain, you should be thinking, what can x be? Well, x can be any real numbers except for certain things that you need to look for. You can never divide by 0 or taking the square root of a negative number. So other than those two rules, in this case, it's all real numbers. So we just want to make sure that the denominator is not 0. So when it's not 0, you solve this factor, use the zero product property, and you get all real numbers except x cannot be 0, 5, or negative 5. That is your domain. Vertical line test states that this is a function. In fact, this is a sine function. Evaluate for f of x minus 2. So you will replace all the x's in your function with x minus 2 and simplify, FOIL, collect your like terms, simplify as far as you can, and then leave that as the answer. Given f and g functions, find g of f of 3. First, use the 3 for the f, going backwards, and you get 10. Then you use that 10 for g, and you get 7/10. Graph this function. Easiest way to graph this is to find the 2 points that are the x and y intercepts. So first we're going to find the x-intercept. Let y be 0. When putting a 0 in for y, we get negative 2x is equal to 12, which means that x is negative 6. Then we find the y-intercept, put 0 for x, and then we find that y has to be 4. So we put that point on there. We have 2 points. We can go ahead and draw a line in there. Find an equation in slope-intercept form. That's y is equal to mx plus b for a line with a slope of 3 and passes through point negative 4, 7. So we have a slope of 3, x1 is negative 4, y1 is 7, use the point slope form. And we're putting all that in, distribute the 3 to the negative 4, we get 12, adding 7 to both sides, we get 19, and that's your equation in slope-intercept form. Write the equation in standard form for the equation of a line that passes through negative 2, 8, 9, and negative 4, 2. Standard form is ax plus by is equal to c. And let's see here. First we find the slope, which is 7 over 2. And using that in point slope form, distributing the 2 to the left and the 7 to the right, we get this. Standard form is when we have x and y on the same side, and that's the final answer right there. Determine which are parallel. So you're going to find the slope for any of these, all of these, solve these for y, and you'll find that these all have a slope of 2, and this one has a slope of negative 2. So these are parallel, this one is not, because they're not the same slope. Graph the function. The first the first piece of this function is y is equal to 2x plus 3, but we only want the part of the graph that's less than 2. So we're going to go from x is equal to 2 on to the left, and then graphing the other equation, y is equal to negative 2x minus 3, and then we only want the right side of that from 2, so we're going to only use the right side of that graph where x is larger than or equal to 2, so that's a solid dot, and this is an open dot because there's no equal sign on the one on the left. Graphing absolute value is always a v when you see that on your graph. If you don't know how to graph it, make yourself a little t-table, guess some numbers, fill in your y's by plugging them into x. When you graph it, you should get the v that has a vertex at 0, 3. Okay, to graph this function, you're going to get the x and y intercepts. The y-intercept will be at -3. X-intercept is going to be at +3. And you're going to draw a solid line through there because of the equals on the inequality. And then because when you're solving this for y, you have to divide by -3, and this will flip the other direction. That means you will shade down on this line. Solve the system by graphing. You can graph the first equation. You can also use this by x and y intercepts. Put a 0 for x and y, you'll get a 2, and +2 on x and y. And then on the other one, you solve this for y, so you can have a y-intercept at 11, and the slope is -4. Once you move the -4 to the other side, you get this line, and where they cross is at 3, -1. Solving this system of equations by elimination, I can add these two equations together and eliminate the y's, and I get 3x is equal to -12. And dividing both sides by 6, I get x is equal to -2. Putting the -2 back into any one of these, and I'm going to use this top one. Putting the -2 back into the top equation, I get 3 times -2. Add 6 to both sides, cancel out this -6 right here, and I get -4y is equal to +4, so y is equal to -1. So the answer is -2, -1. Graphing these, this system, we'll start at the 3 and do a slope of -2. That line looks like that. 3 up 2 back 1. And then on the other one, start the 1 and the slope of 6. Oh, by the way, this is shaded down because it's less than. And this one should be a dashed line because there's no equal sign on this. And then you shade up on that one. And where you're really shading is this part right here. And just remember that this line here with the positive slope has to be a dashed line because there's no equal sign on the inequality. Okay, find the equation of the line where it's symmetrical on this graph. This graph is really a parabola where the vertex is at -2, -3. So there's my vertex, -2, -3. And the parabola is symmetrical about this line right here, which is x is equal to -2. Graphing this, you can use the graphing calculator, or you can use a little t-table, and you'll come up with a graph that looks something like this. Solving an absolute value inequality, get the absolute value by itself, add 9 to both sides. Once you have the absolute value by itself, you can split that up into 2 inequalities. So you have 2 minus 3x is less than 15, and then on the other one you will switch the inequality and make this a -15. Solving both of these algebraically, you'll get x is greater than -13/3, and solving this one you get x is less than 17/3. Putting this together, you're going to have x is between -13/3 and 17/3. This notation just says that x is such that this is going on. Okay. All right. Given a function, find its inverse. You're going to take the y and the x, and you're going to switch them. Once you switch the x and y, solve for y again. Divide by 3. Take the 6th root, and that cleans off everything on here on the y. And since this is an even root, you get a plus or minus. And just rewriting the 6th root as an exponent, you get 1/6. That's your final answer. This is not a function because if you remember that even exponent on the x is going to make a graph look like a W, or it's going to go up to the left and up to the right. when you turn it on the side, that's what the inverse does. When you turn it on the side, you're going to have the lines going sideways, and that means that it's not going to be a function with a vertical line test. Find the vertical and horizontal asymptotes. The vertical asymptote is where the denominator is 0 because you can't divide by 0. So you set the x minus 3 equal to 0, and you're going to find that you have an asymptote where x is equal to 3, which is right here. That's an asymptote. For the horizontal asymptotes, you compare the x's with the biggest exponent. You're comparing both of these. And in example where the numerator exponent is larger than the exponent in the denominator, it's bigger on the bigger on top, then there is no horizontal asymptote. If it's bigger on the bottom, then you're going to have y is equal to 0 as your horizontal asymptote. If the exponents on the numerator and denominator are the same, then you take the ratio of the coefficients, in this case it's 3 and 7, that'll give you the horizontal asymptote. And in this case, the exponents are the same, so the ratio of 2 over 1 is 2, and that's your horizontal asymptote. Give the equation whose roots are -2, 1, and 3. If these are the roots, these are my factors, because this is what makes this 0, right? And this is what makes that 0, and so on. So you're going to FOIL this all out, FOIL them 2 at a time. That's the first 2, that's the third one, FOILed out, and that's your final answer. Solve by completing the square. You're going to add something to this to make this a square, which is going to be half of -6 squared. Half of -6 squared is 9. Add 9 to both sides. And you get x minus 3 squared. That's this part factored. Is equal to 25. Take the square root. Taking the square root of a square gives you a plus or minus the square root of 25, which is 5 and -5. Add 3 to both of these answers to get the x's, which will give you x is equal to 8 and -2. Find the number of possible positive zeros. You count the sign changes. There's one sign change from negative to positive, from positive to negative, and negative to positive again. So there's 3 up to 3 maximum. Then if you put a negative in here for the x, negative for all the x's, you're going to see that this stays this one will stay the same sign because it's even. This one will reverse this positive to a negative, and this one will remain the same. So now you have positive and then one sign change here. And using the fundamental theorem of algebra, we'll have to add up to 4. So the number of zeros have to add up to 4, so I have 3 plus 1. So there's no room for imaginaries. But imaginaries come in pairs, so we can have a pair of imaginaries. If we had 2 imaginaries, then we can have 1, 1, and that also add up to 4. And there's no other possibilities. So the number of possible positive zeros would be 3 or 1. Solve this proportion. So you're going to cross multiply like that. FOIL. Subtract x squareds. Add the 6x. Add the 24. And you can get 32 is equal to 4x. And x is equal to 8. Solve this 2 fractions inequality. Find a common denominator, which is 35. So you'll multiply this fraction by 5, and this one by 7, and this one by 35. And then you're going to get a common denominator of 35, so I can throw away the denominators. Now the numerators add up to 12x is greater than 315, dividing both sides by 12, and reducing this by 3, and we get x is greater than 105 over 4. Solve. Square both sides, and the square cancels the square root, but you do have to FOIL this side, and you get x squared minus 2x plus 1. This is a quadratic. Make this equal to 0. Move all this to the other side. Subtract the x and subtract the 6, and we get x squared minus 3x minus 5. That is not factorable, so we have to use our quadratic formula. And cleaning that up a little bit and a little bit more, and we get x is equal to 3 plus or minus the square root of 29 over 2. Solve this cube root equation or inequality. Cube root both sides. That clears the cube root. And cubing 2, we get 8. Subtracting the 2, we get x is less than 6. Find the sine, cosine, and the tangent for angle A. So here's angle A. We know that the Pythagorean theorem will give me the third side, which is the square root of 106. And sine is opposite side to angle A is 5, opposite over hypotenuse. And just rationalizing the denominator. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Find all 6 trig functions. So using the Pythagorean theorem, we get 12 on this side. Because the hypotenuse is 13, we have to subtract. Then all the SOHCAHTOA relationships or ratios are down here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. And then take the reciprocals for the reciprocal identities. If tangent of theta is 4/3, find sine of theta. So here is my triangle, opposite over adjacent. That is my tangent. And using the Pythagorean theorem, I get 5 for the hypotenuse. So now sine is opposite over hypotenuse, which is 4/5. Find the tangent of theta. If theta is an angle in standard position and the point with the coordinates 3, 4 lies on the terminal side of the angle. The terminal side is the side of the angle that is turning. The side that doesn't turn is at 0. So that 3, 4 is this point right here, and this is theta. That's the angle I'm talking about here, because this is the terminal side right here, is the hypotenuse. So opposite is 4, adjacent is 3, and we want to find tangent, and tangent will be opposite over adjacent. Find G, side G, round to the nearest tenth. When this is round, you're going to be using your calculator. So we have adjacent and hypotenuse, that is cosine. So we take the cosine of 32 is equal to adjacent over hypotenuse. Multiplying both sides by 14, putting this in my calculator, I get 11.9, rounded to the tenths place, 1 decimal point. Solve the equation if we're using radians, one circle from 0 to 360. So we're going to be given cosine of x is equal to negative rad 3 over 2. From the unit circle, you see rad 3 over 2 is right here for cosine, comma, sine, right? So we know that we have an angle of 30 degrees. But it's negative, so negative is going to be over here at 150. Okay, and look where else it's negative. It's also negative right here. So it's 150 and 210. We're doing this again. We're in degrees. Tangent is 1. So you're going to take the ratio of sine over cosine has 1. So sine over cosine, this is 1, so we have a 45-degree angle, and it is also positive 1 over here, negative divided by negative, so we have a 45-degree and 225 degree. Alright, evaluate. All angles are in quadrant 1, so we're going to draw a triangle in quadrant 1, and cosine is rad 3 over 2, which gives me 30 degrees. So cosecant of 30 degrees will be 1 over sine of 30 degrees. And sine of 30 degrees is 1/2. So the reciprocal of 1/2, or 1 divided by half, is 2. Solve for s, round to the nearest tenth. So we have opposite and hypotenuse, that's a sine function. Sine of s is equal to opposite over hypotenuse, multiplying both sides, or actually, taking the arc sine to cancel out the sine, we get S is equal to the arc sine of 21.8 over 25.3, and that rounds to approximately 59.5. You're not getting these answers, make sure your calculator is the same mode as what you're doing. And in this case, this is in degrees. Make sure your calculator is in degrees. If these measurements were in radians, then make sure your calculator is in radians. If the right angle ABC, A is 34 degrees, B is 10, and C is the right angle, solve the triangle. First thing I would do is to draw the triangle. C is my right angle. A is 34 degrees, and so that leaves this angle here is B. Filling in my number of 10 for side B. Side B has to be opposite angle B, so 10's over here. And we can immediately get angle B because we know the three angles in a triangle add up to 180. So we get 56 degrees for B. Now we can use either tangent to get side A, or we can use sine to get side C, or the hypotenuse. So using the law of sines, I have a pair here, pair of B's and a pair of A's, so I'm going to try to find side A first. Multiply both sides by sine of 34 degrees to get A by itself. Then putting this in my calculator, I get 6.8. Now that I have two sides of a right triangle, I can use the Pythagorean theorem to find the third side, and that's 12.1. Okay, here's the triangle ABC. Angle C is still the right angle, but we're not given another angle, so we have 7 and 15. Drawing this properly, we have the side opposite angle A is 7, and the side opposite angle B is 15. Using the Pythagorean theorem, or actually we could use tangent, which we're trying to find side angle A is opposite over adjacent. So taking the arc tangent of 7, or both sides, so get arc tangent of 7 over 15 is approximately 25 degrees. Now that we have this, it's pretty much the same as the last problem. We can subtract them from 180 to get 65, and then using the Pythagorean theorem to finish that is 16.6. The area of a triangle is base times height divided by 2, and in this case the height of the triangle is going to be the sine of 50 times the adjacent side. So this is the height. So base times height divided by 2. So we have 10 times 50, or times 5 times the sine of 50 over 2, and my calculator tells me that's 19.2 feet squared. How many triangles are there that satisfy the conditions 5, 10, and 50 degrees? I'm going to draw this out. This is an ASS, so this is the and this is the one of the ambiguous triangles. So they're either going to be 2, 1, or no triangles. If it's any of these, it's one triangle, and this is also one triangle, but it's not unique. It can be any size, but there's only one triangle that will fit that. If given angle, double check that they do add up to 180. If they don't add up to 180, then there is no triangle. For the ASS triangles, these are ambiguous. For the obtuse, there can be one or none. As long as the opposite side is the longest side, there's only going to be one. But if it's less than, if the opposite side is less than the adjacent side, there is no triangle. But in this case, it's not obtuse, it's acute. This is less than 90. So now there can be 2, 1, or none. If the opposite side is the largest side, then it's just like the obtuse, there's only one. But if it's shorter than the adjacent side, then you have to check the height. The height is the adjacent side times the sine of theta. So in this case, it'll be 10 times the sine of 50, which is about 7.7. And if the height is the medium one, so if it goes adjacent, height, opposite, 10, 7.7, and 5, then there are no triangles. If it's adjacent, opposite, then the height, then there are 2. So in this case, there are none. Change 2.11 radians into degrees, round to the nearest tenths. Multiply that by 180 over pi, because these are equivalent. 1 pi radians is half a circle, just as 180 is half a circle. Times 2.11, you get approximately 120.9 degrees. Going the other way, we have 195 degrees. Change that to radians, but in terms of pi. So you're going to take 195 times pi over 180. This can be reduced to 13 over 12 pi. Unit circle with a radius of 9 centimeters. Find the arc length S, subtended by a central angle of 15 degrees. So here's my subtended or intercepted arc of S. The angle's 15 degrees and the radius is 9. You will need this formula here, where it's this length of the arc is over 2 pi r is equal to theta, the angle, and over 1 full circle. It's either going to be 2 pi or 360, depending on what units the angle is given in. In this particular problem, we're given the angle in degrees, so we have to use the 360. If the angle is given in radians, you would use 2 pi. So putting these two numbers in, we'll put the 9 in here and the 15 up here, using the 360. Solving for S, moving everything to this side by multiplying by 2 pi times 9. Reducing this or using my calculator, I get 3 pi over 4 centimeters. That's the length of this piece of the circle, the arc. Find the value of tangent of arc sine of rad 3 over 2. The unit circle says the arc sine of rad 3 over 2 is 60 degrees. And the tangent of 60 degrees would be sine over cosine, and these two denominators cancel, so you get rad 3 over 1. Given that cosine of theta is 3 over 7 and the cosecant of theta is less than 0, find sine and tangent. Cosecant is less than 0 or negative, that means sine is negative. Which quadrant is sine negative and the cosine positive? Well, that's going to be in quadrant 4. Using all students must take calculus. We're drawing my triangle. The angle has to come out of the origin like this. And since we have cosine is adjacent over hypotenuse, we get 3 over 7. And my theta is in here. Now if I want sine, I need to use the Pythagorean theorem to find the side, which is rad 2 rad 10. And since it's in quadrant 4, it's going down. That means it's negative. Now to find sine, we take opposite over hypotenuse, and tangent is opposite over adjacent. Find the cosecant of x if tangent squared x is equal to 1/2. Take the square root of both sides, draw a triangle, so I have opposite over adjacent. That means that my cosecant is going to be hypotenuse over opposite. So we have to find the hypotenuse is rad 3 over 1, right? Hypotenuse over opposite gives me rad 3. Find the sine of x if cosine of x times the tangent of x is equal to 2. Well, tangent of x is sine x over cosine x. And the cosines cancel. Sine x is equal to 2. That's what we're looking for. The answer is 2. Find the exact value of cosine of 105. This is the sum and difference formula. You have to figure out what two angles that you do know of on the unit circle that make 105 when we add them together. That would be 45 and 60. So that means that I can use 45 and 60, which I know. If u is equal to 45 and v is equal to 60, we're going to use the cosine of 45 times the cosine of 60 minus, because these are reversed. If this is a plus, this has to be a minus. then sine of 45 times sine of 60. Getting these from my unit circle, I get these values, and simplifying, I end up with that. Okay, doing the same thing. Now we're going to have a slightly different formula for sine. Now the signs are the same, plus minus, but it's sine, cosine, cosine, sine. So now we have 75, it's really 45 plus 30. Putting this all in for u and v up here, we get this, and simplifying, that's rad 6 over rad 6 plus rad 2 over 4. Given the vectors of u and v, find 4 times u minus 3 times v. So we're going to 4 times u would be 28i plus 12j, and 3 times v is negative 12i plus 9j. Now since I'm going to be subtracting these, I'm going to take 28 minus a negative 12, and we're going to take 12 minus 9, and I get what I was looking for, right? This is what they asked for, is equal to 40i plus 3j. Without wind, a plane would fly due west at a rate of 200 miles per hour. The wind is blowing southwest at a rate of 40 miles per hour. The wind is blowing at a 45-degree angle from due west. What is the actual speed? So we'll want to know the actual speed after the wind has pushed the plane this way. I'm going to call the plane u, and it's going to have all of its magnitude going to the left, so I'm going to say that's negative 200i. Now on the wind, v, it's going to be 40 miles per hour, but it's going southwest, and that's 45 degrees. But on my calculator, on my unit circle, that is really down here in quadrant 3, which is 225 degrees. So now we know that the horizontal component is 40 times cosine of 225, and the vertical component is 40 times sine of 225. So here's my horizontal component. It's 40 times cosine of 225, and my vertical component is 40 times the sine of 225. And putting that in my calculator, I get these values. So the horizontal portion, it would be negative 200 plus negative 28, and then the vertical component will be 0 plus negative 28. So we get these values for my sum vector, my resultant vector. We need to find the magnitude, which is just the Pythagorean theorem. We're going to square both of these and add them together, and then take the square root. We get 220 miles per hour. The resultant of two forces acting on a body has a magnitude of 50 pounds. The angles between the resultant forces are 30 and 47. Find the magnitude of the larger force. So here's some force that's 50 pounds. That's my resultant force. It's the result of two forces, one here and one here, being pulled. These two, you can think of a rope pulling on a boulder here by these two people, u and v. One's pulling this way and one's pulling this way, and the boulder's actually moving this way. They're helping each other, but they're not quite pulling in the same angle. So we're going to do kind of the same thing as the last one, but you just have to be careful. This vector here is fine because vector u is a 30-degree angle, but vector v is actually a 313 angle because you have to come all the way around here. Okay. Okay, so u is going to be the magnitude of u times cosine and sine of 30 degrees. And v is going to be the magnitude of v, which we don't know. Okay, the magnitudes of these two forces we don't know, so these are variables that I have to keep here of 313. So writing out the cis formula, we get this for these two. Putting these in my calculator, or well, before I put them in my calculator, I know that the vertical and the vertical components have to cancel out. So I know that this portion right here, as much as U is pulling up, has to be equal to the V pulling down. Otherwise, this R would not be going straight across, because this R has no vertical movement. It only has all of its movements to the right. None of it's going up and down, so that I know these two have to equal each other. The vertical movements have to equal each other. So one's pulling up and one's pulling down, so I put a negative sign on here. And then solving this for the magnitude of U, divide both sides by sine of 30. And putting that in my calculator, I get this, which is going to give me 1.4627 times magnitude of V. The two negative signs cancel out. Okay, so and I know the horizontal components, these two added together, have to add up to 50 because that's the resultant force. So when I add these together, I get 1.9487 V. Okay, and then dividing both sides by 1.9487, I get 25.66. That's solving for V. It's dividing both sides by 1.9. 50 divided by 1.9. And if I know that's V, I can always put that in here and get U. So these two are my two forces, and it looks like this is the bigger force, so that's my answer, because it said find the magnitude of the larger force. Okay, the slope of the line should be -1. Find the equation of the circle. Well, you know that the circle standard form of a circle is this, and this is my center, so we're going to get this for my answer for the equation of that circle. Completing the square, factor out of 3 and factor out of 5, I get this. What I need to complete the square here is a 9. 9 times 3 is 27. What I need to complete the square here is half of 8. Squared is 16. 16 times 5 is 80. Simplifying this a little bit, I get this. And an ellipse has to equal 1, so I'm going to divide everything by 25. So I'll get 25 over 3 plus, and this reduces to 5. Graph the conic. Well, I know that A is 4 and B is 1. So A is the distance from the center, which is at 0, 0, and go out 4 in each direction, and go up 1 in each direction in the y direction, and 4 in the x direction, and that's my ellipse. This is a hyperbola with a minus in between, and first thing I need to do is make this equal to 1. So there's my hyperbola, and now A is going to be 5 and B is going to be 3. So I'm going to go out 5 in each direction and 3 up and down, draw my asymptotes, and then just sweep out my hyperbola. And we know that hyperbola goes left and right because the x is positive and the y is negative. If the y was positive and x was negative, it would open up and down on the y-axis, but now it opens on the x-axis. Identify the conic. If the x squared and the y squared are both positive with different coefficients, then that is going to be an ellipse. If they're the same coefficients, then that would be a circle. If one was positive and the other one was negative, it would be hyperbola. And if only one of them was squared, that is a parabola. Okay, simplify. You need to take this, would be 4x cubed y to the negative 6 times 4x cubed y to the negative 6. That's what the squared means. You're going to end up with 16x to the 6 y to the negative 12. And then we need to move that negative exponent to the denominator. Okay, simplify. Exponent to an exponent, power to a power. You multiply those, and I can reduce this to a negative 1/2. The negative exponent means to take the reciprocal. The 1/2 means to take the square root, and we get 1/8. Evaluate the expression, the log base 3 of 1 over 243, and I know that if I'm looking for base of 243, 3 times 3 times 3 times 3 gives me 243, so it's 3 to the 5th power, and because it's in the denominator, it's going to be negative, and a log base 3 cancels my base 3 here, which gives me a negative 5. Solve. So rewriting this in exponential form, the base is 2, the exponent is 4, so x is equal to 16. This is a change of base problem. You have to log some kind of log, whatever log you want to use in the numerator and denominator. Then this will be the log of this, the value, over the log of the base 4, and that's about 3.62. This is the same thing except it's an inequality, so the log base 5 of 150 is equal to the log base 10 of 150 over the log base 10 of 5, and that's about 3.11. Form a sequence that has two arithmetic means between -12 and 51. So I want two means between here. If this is the first and that's the fourth, that means my common difference is going to be like the slope, 51 minus -12 over 4 minus 1. That will give me a common difference of 21. So each time we're adding 21, so that'll give me 9 and 30. Find the sum of the first 25 terms of the sequence, 3, 7, 11, and 15, 19, all the way up to 25 of these numbers. So we know that this is arithmetic because we have a common difference of 4. And this is the sum that I need to use. But first I need to find the 25th term. I have the first term, which is 3. I have the number of terms, 25, so I'll need the 25th term. In order to find any term, particular term, I have to use this formula. So I'm going to take the common difference times the term that I want plus the one before the first term. The one before the first term had to be a -1 because I'm adding 4 each time to get to 3. Alright, so now putting this in here and then 4 for D and 25 for N, I get 99. Putting this as my last term, 99, I get this. So my sum of the first 25 terms is 25 over 2 times 102, which is 1575. Now let's go to geometric means. We're going to find two geometric means between here. And I know that's the first one, and that's this fourth one. And I can use this formula here to find R. And this is the fourth term, first term. That means R to the 4 minus 1. Putting the fourth and the first term in here, dividing both sides by 11, taking the cube root, I get R is equals -3. So if I'm multiplying by -3 each time, the next term better be 33. -99 and positive 297. Find the sum of the geometric sequence. Make sure that these are going down before you can find the infinite sum. ... means infinite, and they do get smaller, so that's okay. So now I'm going to find R. R is the second term divided by the first term, or any two terms. You can take the third term over the second term, or the fourth term over the third term, and you still get -1/4. Using the sum formula for infinite series, we have the first term over 1 minus R, so that'll be 8 over 1 minus a -1/4. So it'll be 8 divided by 5/4, which is 8 times 4/5. We'll get 32 over 5. Find the fifth term for the expansion of this binomial expansion. From this, we need this formula where R is 1 less than the term that we're trying to find. I is 5. We want 1 less than that for R. So now we know that N is 10. I is 5, which makes R 4. Putting my numbers in, I get 10, C4. 2x to the 6, and -7y to the 4th. That's my A and B. And then you can just leave it in that form. That's the way it's going to show up on the final. You do not have to know how to do 10C4 to get to 10. How many ways can 7 books be stacked on a shelf? Well, that will be 7 factorial, which is 50, 40. How many different ways can the letters apple be arranged if the first letter must be A? So if the first letter must be A, there are the possibilities of 4 letters left over. So we're going to take 1 times 4 times 3 times 2 times 1. And then we have to divide that by 2 factorial because we've got 2 P's. And that will be 12. How many 4-digit numbers can be formed from the digits 0 to 9? And the first one can't be 0. That'll be 9 times 10 times 10 times 10, which is 9,000. How many committees of 5 people can be chosen from a group of 20? Well, that'll be 20 times 19. You're going to take 5 people, but you can't tell the difference, so you have to divide that by 5 factorial. Or you can use 20C5. The answer is 15,504. From a list of 3 country songs and 5 rock songs, how many groups of 2 country songs and 2 rock songs can be on a playlist? That'll be 3 choose 2 times 5 choose 2, which is 30. A bag of 6 red marbles, 7 white marbles, and 4 blue marbles. How many ways can you choose 3 red, 2 white, and 4 blue? That'll be 6C3 times 7C2, 4C4, which is 420. How many 5-letter permutations can be formed with the letters in the word apple, which would be 5 factorial over the 2 P's that we couldn't tell the difference, would be 60. 2 coins are tossed. Find the probability that one coin is heads and the other one is tails. This is all the different combinations. This is the total sample space. And how many of them are 1 heads and 1 tails? 2. So 2 out of 4 is 1/2. Send a deck of 52 cards. 2 cards are selected without replacement. What is the probability of both cards selected are kings? Well, if you select 1 card, it will be 4 kings in the deck out of 52. Once you take that one away without replacement, there are only 3 kings left and only 51 cards left. And that will come out to 1 over 221. This is for those who want to be able to identify graphs of polar coordinates. Okay, you need to make sure your calculator is in polar coordinates. These are some names of the shapes that you will see. This is a cardioid because it looks like a heart, cardio. And this is a dimpled limacon. This is a convex limacon, and this is a limacon with an inner loop. And if it looks like a flower, we call these rose curves. And if it looks like an infinity sign, we call these lemniscates. Okay. All right, that's it.